we got a huge crowd. Ann, would you like to say? No, you can talk in public comment, okay? We'll call the meeting to order. Issues or items that are not on the agenda may be raised by the public at this time. Citizens should speak from the podium, begin by stating their name, and limit remarks to less than 3 minutes. Board members may request that a discussed item be placed on a future agenda. The Water Advisory Board takes public comment on all regular agenda items during discussion of those items. Is there any public comment? As our former mayor would say, if any of y'all want to get up now and come talk to me. Ricky, you got anything? Okay, move forward. Let's look at the minutes. Y'all all got sent the minutes. Last time we met was November the 17th. I'll entertain a motion or any adjustments to the minutes. Motion to approve. Kendall, second. Judge? Discussion. All in favor say aye. Aye. Any opposed? Thank you. Water Utility Fund report. Bill?
Gentlemen, good to see you all. I'm not going to take a lot of time here, but this was a presentation that we made to the council recently on the water fund and some of the changes that we're looking at in the 5-year plan. And so I want to just kind of go through that with you and then maybe start some discussion on how we need to look at how we're going to pay for water supply and infrastructure rehab in the future and how that relates to the financial condition of the utility. Got the wrong presentation. We're going to try again. All right. So, just to start with, let me tell you that the plan that was adopted by the council, the 5-year plan, is for the most part tracking just as predicted. With O&M is tracking just pretty much right on target, but we have made some significant changes, mostly in the assumptions for the capital costs associated with water supply and improvements. So just looking at the graph here, it kind of shows that for 2016 and 2017, we're tracking right on as far as our revenue requirements and revenue. But as we move out into 2018, 19, and 20, you see that green line shows where our current revenue would be if we did not continue with the 5-year plan, and we would not be able to continue to meet our financial targets. So what I want to do here is I'm going to take just a minute. I've got a lot of slides that look like this, but it's each year projecting out in both water and wastewater what our total revenue is projected to be with our expenses, and then the bottom number there is of course what we would have available at each year to push into the fund balance, again, to meet our financial targets. And I want to go through this in this detail because it kind of shows some of the fluctuations that we have from year to year in what's available to go to the fund balance. So to me, it means that in order to look at the whole financial picture, it's not a 6-month or 1-year picture. It's why we look at it from a 5-year perspective, so we can see a trend of the increase in the fund balance. But just to really quickly look at this, and this again as example is we're projecting out. Let me back up. This is actually actuals for last year, so it was right on target. Well, it was actually about $500,000 low, I think, in what we thought the surplus would be. This year is projected for again, but you can see that the surplus, because of mostly capital costs, we'll have less to push into the fund balance in 2017 and 2018. But then as we move out into 2019, we would see, based again on projected revenues and expenses, that we would see a little bit more to push into the fund balance. And so we would see our financial targets begin to be realized on our minimum 75-day cash on hand, and then out into 2020. Wastewater is the same. This was in 2016, was actuals. And then as we move out, we get out to 2018. But then in 2019, we'll see, because of, again, capital costs, we'll see that will dip a little bit, and our expenditures and revenue will kind of come back closer together. So again, the point in that is just that it's important to me to look at this over a longer period of time. Since we have our revenue is impacted considerably by weather. That's Jonathan's fault, but the more rain that we have, obviously, the less water we sell, and so when we did the rate plan, we tried to normalize that, and so you look, in looking out over that period of time to take that into account, but it's still. Obviously, it's somewhat of a guess, even though it's an educated guess as you look out 5 years of what our expenditures are. But all that's to say is the current plan is tracking as projected. There were some changes that we made in the plan, specifically in the capital associated with alternative or future water supplies. This is what the original plan showed, that we had $56 million that would have been borrowed in 2017 in the wastewater fund and $80 million in the water fund in 2018. And if you'll recall, those were numbers that we just, we developed those based on some specific projects, but they were placeholders, if you will, knowing that we needed to do something, and so that was how we would provide funding for that. The changes that we made show that we've got the ranch project at $45 million in this year, and then we projected that there would be approximately another $35 million pushed out to 2020 in the water fund. And then for the wastewater fund, we've moved the $56 million from 2017 to $20 million in 2018 and $36 million out in 2019. That includes, for both of these, the projected or needed improvements that we're going to need to the wastewater treatment facility and the water treatment plant. And we'll talk a little bit more about that in the future on what we had talked about at our last meeting about a plan or a project to develop a long-range plan with funding and timetable for improvements, and that's still moving forward. We'll be talking to the council about that in the near future. This is, at this point, a best guess on kind of the time frame that we think those expenses would hit the utility. So,
on the water treatment facility update, does any of that move towards a better filtration system? I'm not talking about what we talked about on reuse and how we're going to pull it, but anything on going towards some type of better filtration system that we've looked at, like at the conference and so forth?
Yeah, I think that any improvements to the water treatment plant would include probably a much upgraded treatment process. Okay. I think the objective there, and again, it's part of what we need to look at in the overall plan, is a facility that would treat multiple different types of water sources.
And everything we're seeing right there is borrowed money?
Yes.
The projects that were ongoing right now that we're in the midst of, or just your normal stuff, and like I was asking, the Chaburn Street and whatever else like that, that's paid from cash?
I'm going to talk about that in just a couple minutes. Okay. At the end of this.
Bill, if I may, so under the wastewater fund, alternative water supply, that goes back to the plan of treating the wastewater to a level that it could get discharged, and that project, is that what that entails, or is that something? No,
that's exactly right, Stan. And that's why I left that word in there, because I think that part of what we need to look at for the future is not necessarily direct potable reuse, but we have 7 million gallons to 9 million gallons a day going out there that could potentially be used as some source to augment our surface water supplies. I think we need to continue to explore that.
So when are y'all talking about bringing that in more detail to us? So we can at least, I just want to get the 20,000 foot level. I want to go back. It's been so long. I think we need to look at the scope again.
Well, I intend to take it to council in June.
Okay.
Bill, I have a question for you. So there's no no hindrance or challenges with the receiving the permit to do that, or is this banking that we already have the permit?
Lots of challenges with that.
Okay.
Well, there's two things.
What happens if we don't get the permit? Then we refund the customers, or what do you do with the funds?
Well, that's an interesting question, Roland. This isn't about a single project. This is about finding a future water supply or augmenting our supplies for St. Angelo. And so if we didn't get a permit to put the effluent into the river, we would do something else. We would look somewhere else. I mean, there's a lot of issues out there and possibilities that we need to continue to explore. We don't stop. I mean, something has to be done. And so that's an interesting question, and I think there was some confusion about that even with the direct potable reuse project, is that we had funded that, and when the council decided not to do that we didn't need the money. But as we've said a lot, embedded in that project was improvements to both wastewater and water treatment plant that still need to be done. Besides the fact that we have not made any real strides towards how do we augment our surface water supplies or our water supplies. So I think that's still out there, and we've got to pay for that. So we've got to have the funding to do that, and that's what this is about.
But to Roland's point, from a permitting perspective, that there are steps being taken along currently.
The project to develop a plan has got to be done. That's a preliminary
Right.
engineering project that would identify how you would treat the effluent.
Right.
And then that has to be done to be able to apply for a permit. That's a multi-year process. Along with that would become, potentially would be the need for a bed and banks permit if you're going to pull that water out downstream somewhere. That's another multi-year process to get those permits. Are they guaranteed? No. Is the discharge permit more likely? Absolutely. The bed and banks permit is a little bit more difficult, but they're both very doable. They just take time and effort.
So if you're going to take, I'm back to alternative water supply, to council in June. What's the date? What's that meeting date?
That's the 13th, I believe.
So we need to meet before that. I think we'd like to know what's going to be presented to council.
Well, I presented that project and scope to y'all previously, and you recommended that we move forward with it.
I can't remember, sorry. Then why don't you send it back out to us again? Let us look at it. I mean, we need to be on board. Just up to date with what's going on. I would hope somebody from council would call, especially the new ones, and say, what do you think? What's going on? Are you okay with it or something?
Well, I'm going to tell them you are.
No, but I mean, they need to converse with us.
As far as you know.
Yeah, okay.
Okay, just to kind of show on an annual basis the difference in the moving of the capital expenditures throughout the 5-year plan, just kind of shows how it impacts us on an annual basis on what our debt service is. So obviously it's a little bit higher in 2017 in water than had originally been projected, but then in the next 2 years it's lower, and then kind of catches back up out in 2020. Wastewater is the same. It actually it spreads that out over the 5 years a little bit more so that it stays lower on each year as part of the 5-year plan. Looking at the fund balance, the current fund balance, or at the end of April for the water fund, was about $822,000. The estimated fund balance at the end of this year is a little over $3 million. And then, of course, our 75-day goal is 4.7, just under $5 million. On the water fund, or the wastewater fund, rather, the fund balance at the end of April was a little over $9 million. With the estimated at just a little over 4. And the reason for that is there's a project embedded in this that's actually in this fund that would show up on the financials. It's over $4 million for a sewer project that was some older bond funds that were moved into this expense account to pay for that project. And so kind of distorts this a little bit, but want to make sure that we showed the real number. And so, but the fund balance, the wastewater fund is obviously doing better than the water fund. And so we will be above our projected goals at that time. Bottom line, as far as the 5-year plan, is that we think we need to continue. It's on target. It's meeting the targets that were set, and to meet the improve the financial position of the utility. Hopefully, if we continue in this way, we'll meet our financial minimum 75 days in 2019. So back to the discussion of how we fund projects. I had presented to y'all an idea back at one of the last meetings on the infrastructure rehabilitation needs of the city, which are considerable, and in a way to keep up with the street plan, to actually use the money that we've set aside in the 5-year plan for cash funding projects, to leverage that and use it as debt service so that we could borrow larger chunks of money to be able to do bigger projects and keep up with the street plan. Quite honestly, I've kind of rethought that process a little bit. And I think that there's maybe a potential to be able to cash fund those projects as had been originally thought. But to do that, obviously you have to have cash. The council's current policy is to evaluate the fund balance every 6 months and to look at the potential of rebates. I understand the importance of watching our financial position, but the truth is, like I said, if we're going to actually cash fund projects, we have to have cash above what our financial targets are. So we're going to have be able to have the ability to bank that, to be able to have enough money for specific projects. So I just want to kind of start that discussion of how we would. We're taking a look at how we would be able to, if we would be able to do that without having to borrow any more money. But we have to have the policy has to be able to have that available cash.
Where do you expect the excess cash to come from? If we're not meeting our funding balance right now, where's that influx of cash? Is it going to come out of the general operating account? Is it some other?
I think if you look at this chart, Mike, as you see that after we move out, we begin to exceed our 75-day goal, and I think that we would.
Yeah, that's like in 19.
It is.
So
right.
I guess, Mike, it's been a long time since we met. Some of y'all asked me. You remember we went back and we've got the top 25 street projects, and we're working on that with MLK and Bell, and we're waiting on the report that's due on our infrastructure June. Sometime this summer, and then that'll give us our top 25 infrastructure projects. And those two, at least from what I've been telling people, they're going to overlay, so we make sure that as we go through MLK and Bell, we replace the infrastructure underneath or to the side, which makes a lot more sense. And then we'll follow that down through those projects. So, I mean, we're going to need to, the city's going to need to borrow money to start when that reports here now that we start on street number 3 or number 4 or number 5.
And that's still
That's still going to happen. That's what my question is.
It's still a real possibility that we can't cash fund it.
Yeah, there's no way.
But if I definitely want to step back and take a look at that and cash fund as much as possible.
It's going to be a couple of years down the road at the earliest, you know. The other thing that I'd like to do, and not to interrupt you, is, you know, we've not done anything from a paper standpoint keep the community updated on what's going on. I mean, I know the city came in and we talked about let's leave the rates the same. You know, mayor wanted to try and get a reduction, get a rebate, which doesn't make sense. We need to tell the community that we're meeting our plan. Here's what our cash flow has been. We're still not where we need to be. Our goal is still 75 days. Here's how many days we got cash on hand. I mean, I want to be totally transparent to them. So if we come up and decide we get our 25 top projects, we need to tell them, here's number 3, 4, and 5. It just eliminates a lot of questions, you know? Some of the new council people are already asking me kind of, what are y'all doing? What's going on? How come you haven't met? And we've just been quiet. And I think we need to come out publicly and get Rashta to do it, because the whole paper's changing now, and get her to write us a good report for the public to know that we're doing what we're supposed to be doing. Us, the board and the city, and let them know we're on track. That's just my opinion.
Well, that's a very good point, because again, it's hard for people like to, they see something going on, they see one project going on, it's okay, everything's solved now, it's all good, you know, we don't have to worry about this stuff anymore. So then that stirs up all the discussions again, like Mike's saying, of, okay, well, now you can cut my rates again. No, we have to pay for that. So, you know, we went through all this process, what was it, a year ago or whenever, when we went through the whole rate structure. I think that, agreeing with Mike, it needs to be revisited, it needs to be represented, and saying, here's where we are, here's what's going on, here's why we need this to continue on. I just think, again, it's public perception of what's going on.
We did a presentation to council in November, and we did another presentation to them last month.
Yep.
Publicly.
Council's fine. I want the public to know that we're doing what we told them we would do. It takes the pressure off of y'all, I think, and I think it lets them know that we're following our plan, and we're being mindful of what we agreed to do. And I think it reminds council too, to be honest with you, that, you know, we've got the plan, we agree with it, we're recommending it, we want to stay with it just like you're recommended, and it gives you some support. That's what I'm looking for. Do y'all, I mean, am I crazy? Y'all agree with me?
Crazy, but
I mean, I know I'm crazy, but any public comment we can get from the paper standpoint is good for the city, okay?
good for y'all's department too.
It's good for y'all, that's what I'm saying. You know, they always print the stuff that's fun to read. So let's print newsworthy stuff. Mike Kelly was good about wanting to print positive things, and now we've got a whole change. I talked to Jeff this morning. Everybody's changing. And Rashta's the only one that I know that's still going to be there. And she's good about writing the truth. She did our series of water and did a great job. And so I think we need to get her to ever periodically let them know we're following our plan. And if there's differences, if things change, so be it. But let them know we're going to come up with the infrastructure in sometime late June or say July, you know?
Perception's reality.
Yeah, keep them advised of what's going on.
He might be able to help too.
Well, Anthony's pretty good.
So I think that's a good idea, Mike, and I have some suggestions about how to go about doing that.
Okay.
By the way, I'm Anthony Wilson, the Public Information Officer for the city. We will help with that effort as far as creating some content for our website and our social media and our TV channel. But also, too, one of the great things about the Standard Times is they have that viewpoint section each Thursday, which they accept reader-contributed content. And so what I would propose is let's Bill and Allison and myself work on a piece so that we can deliver the exact message that we want the public to receive. And again, we can repurpose that content for our website, our social media,
And if you
our
want it to
TV
come
channel.
from us, let it come from us, if that helps.
Well, actually, I mean, Stan wrote a piece previously.
Yeah, he
It was,
did.
it was very well written and very good. So I'm open to that as well. So I agree with you. I think it is time that we update the public on sort of how the plan is going, because it does seem to be going according to plan. Yep. And we need to reinforce that for people who think perhaps that the water rate increase is not doing what we sold it to do, when in fact it's doing exactly what we sold it to do.
And it's not quite there because we've had rain. Water usage is down, you know. So anyway, only reason I'm doing that is just to help us.
Well, I'm
That's
not
all.
in disagreement with you at all.
Okay.
That's all that I had on that.
Other questions? Anybody? Okay. Thanks, Bill. expecting 3 inches of rain in the next 2 weeks and around 82 to 85 degrees. Go ahead, Jonathan.
Don't disappoint us.
Jonathan Jennings, I'm with the West Texas Weather Modification Association, also a member of the Water Advisory Board. It's been a while since I've done an update to anybody in Tom Green County as far as our operations go for weather modification. I'm going to give you a brief introduction to Weather Mod in case you're not familiar with it, go over what we've done in 2016 and so far in 2017, and then what everybody likes to hear about the climate outlook, may or may not like to hear. That'll depend on your opinion on what I have to say. But first, weather modification, why we do it. It helps increase water supply for drinking water, irrigation, area, lake, rivers, and reservoirs, and especially aquifer recharge, while we also reduce the need to irrigate or consume groundwater. We do the process by flying aircraft at the base of a convective thunderstorm where we use 2 types of different flares, glaciogenic flares, which contain silver iodide, and hygroscopic flares, which contain calcium chloride. The glaciogenic flares, we target super cold water droplets within the cloud, and unfortunately that's something that's very abundant here in West Texas due to the amount of dust and sulfate we have in our atmosphere. So these are very, very small water droplets within the cloud that are actually too small to freeze, so they become super cold. They're below freezing, just cannot freeze. There's not enough of a surface area. Additionally, they're so small when there's collision and colliding occurring within the cloud, instead of forming into larger particles, they simply bounce off one another. So we introduced the silver iodide, which is structurally very similar to an ice crystal, into the cloud, which then freezes the super cold water, and then we're able to get particle growth a lot more efficiently. The calcium chloride flares, calcium chloride is very hygroscopic in nature, so if you were to put a bunch of calcium chloride in your hand and you breathed on it, it would turn into water. You would just have a bunch of water. We use these to target days when our cloud bases are extremely high, and we also have a lot of very small particles within our warm cloud sector. And we're able to put these particles into the cloud in good distributions, which then allow for a more efficient warm rain process to occur. We get larger particles in the warm cloud process. Those larger particles get pulled up into the freezing level, and they freeze a lot more efficiently. So we've learned over the last 4 or 5 years that the best way to cloud seed here in West Texas is to use a combination of both types of flares, unless our clouds do not reach the freezing level. Then we only use the hygroscopic flares. When I say flares, you can see the picture there. The small flares are glaciogenic flares. Those larger ones are hygroscopic flares. The small flares are about 40 grams. They contain about 5 grams of silver iodide. The large flares are a kilogram. They take about 4 minutes to burn. And they put out a lot of material, more for larger systems. And they simply burn in place. There's a little trigger in the airplane. They fire it. You get a burn just like a roadside flare. The particles volatilize, and they form in sizes and distributions favorable for cloud seeding. So we must have convective storms. This is exactly why we seed mainly during the summertime, or basically from March through October. The convection within the storm ensures that there's inflow present. So we have to fly VFR, visual flight rules. We have to be 500 feet below cloud base. So that inflow we rely on to get to transport the material into the cloud is what we're looking for. This also helps ensure the possibility of super cold water, which on my radar screen I'm able to tell where the droplets are, distributions and all that, and able to tell what the temperatures are. And you can see the pictures here. The top one, that's a glaciogenic flare being burnt down in South Texas. And then the bottom one is here in West Texas. That's a hygroscopic flare. And you can see the smoke trail kind of go back into the cloud there by the rain shaft. So these are 2 really good examples of seeding at the base of thunderstorms. So 2016 operations last year ran from March 7th through October 6th. We had 32 operational cloud seeding days. We seeded 111 total clouds within the West Texas area, our 6.5 counties. 110 flight hours with 1,208 glaciogenic flares and 86 hygroscopic flares. As far as operational days goes, it was pretty below average, actually. We averaged around 40 to 45. But we were able to seed just as many clouds as usual. So we had less rain days, but those rain days were actually more active for us. And the flare usage also shows that it was pretty average year. However, with a 35-inch year here in San Angelo, you would have thought we would have been a lot more busy, but when we get those very low cloud bases below 4,000 feet, we simply cannot fly. You get into IFR conditions, low visibilities, and we had plenty of those days last year. So we send our data up to Texas Tech University, where an independent researcher does an analysis on our programs. And for the West Texas area, he looked at small clouds, which are clouds with a volume less than 10,000 kilotons. And he saw that we had 97% timing. That means we arrived to the cloud before the first half-life of the storm, which we don't know until the clouds pretty much dissipated. We saw increases in lifetime area, volume, precipitation flux, and precipitation mass. The lifetime, we're increasing the storm lifetime by 20 minutes. If you think of a hot air balloon, when you put more heat into a hot air balloon, it actually rises more efficiently, more quicker. When we're turning these water droplets into ice, we're actually releasing heat into the cloud. So we're allowing the cloud to grow vertically much more efficiently, which allows it to extend lifetime throughout a longer time. Precipitation flux is the main thing I take a look at, because that's simply how heavy is the storm raining. We can't make a storm rain. We can only make it rain more efficiently. So we find more heavy rainstorms within our clouds that are seeded. But those small clouds produce an additional 44,000 acre-feet of additional water supply to west central Texas. Large clouds, these are much larger systems. You have an area of over 10,000 kilotons. We saw 100% timing, so it's a lot easier to get to those clouds because they last much longer. The increase in lifetime by 70 minutes, precipitation flux by 31%, and those clouds produce an additional 1.125 million acre-feet of water across west central Texas. And that's where we see a lot of our biggest production of water as far as cloud seeding goes. The third type of cloud we look at are type B clouds, and these are clouds defined as those that develop outside of our target areas but move within our target area or in our buffer zones, and we're able to seed them. So these clouds typically are a lot older, and the older the cloud is, the less efficient it is, and the harder it is for us to see increases as far as cloud seeding goes. So you can see the increases for area volume, precip mass, and flux are all pretty low. But still, these are very large systems usually when they come into our area, so we get pretty good water production out of those. Last year, we saw an additional 100,000 acre-feet roughly. So overall this year, we saw an increase of almost 1.3 million acre-feet of additional water supply across our 6.5 county acre that we seed. So looking at the county by county analysis, you can see where everybody stacks up. Sterling County, 110,000 acre-feet. Crockett County, which is a very large county, 172,000 acre-feet. And Tom Green, here we only seed areas from 277 west of Tom Green County, but the impacts that we do here do impact areas to the east of 277. So we saw 111,000 acre-feet, or an additional 2.7 inches roughly, which is a 10% increase in precipitation. And that may not sound like a lot, but we all know what 2 or 3 inches means here in west central Texas. And if you take that over a 10-year period, we're adding an additional year of rainfall to our 10-year period. So it's important to note that this is a long-term water strategy management tool. We're not here to fill up Lake Ivy. We're not here to break a drought. In fact, drought years were actually less efficient because there's simply not enough resources for us to work. So it's the really wet years when we get out there and try to bank the water, so to speak, for years like 2011, where we simply didn't have much to do at all. So very important to note that this is a long-term water strategy. Historically, on average, about 1.24 million acre-feet a year, so we're right there on average. The average for Tom Green County is about 2.02 inches per year, and that's from 2004 on. And this chart here is very interesting. This is a 5-year moving average of percent of normal rainfall for 15 rain gauges within the target area and 15 rain gauges outside of the target area. And you can see from basically 2002 on, we were doing pretty good. The blue there is within the target area, the green is outside. And on the right there, you can see we were about 100% of normal since 2004, where outside of the target area was about 88% of normal, and that's a difference of about 12%. So the analysis that's done via the radar that is done up at Texas Tech seems to be pretty close to what we're actually seeing on the ground. And also what's interesting on this chart, if you look back to the late 80s, early 90s, that's when there were research experiments going on from San Angelo to Big Spring. So we were actually seeing a positive trend there during those research experiments as far as precipitation goes. So this year so far has not been very active. Usually by now we have about 10 operational seeding days, but this year we're only at 3. We've had a lot of overnight activity. It seems like the dry line sits just to the west of the area, starts to retreat, then a cold front comes through, and next thing you know, you have a bunch of showers and thunderstorms coming through during the overnight hours. The dry line's been present and just hasn't been active until it gets support from the cold front. And it seems like the days that we have really good chances for thunderstorms, we have too much moisture in the mid-levels, which clouds up our atmosphere, keeps things pretty cool, so we're not seeing that strong convection just yet. But it's still very early. We typically get very busy late May, early June, and that continues through August and September. Any questions about the weather mod aspect of things? I'll take more questions at the end if you think of any.
The flares and stuff that you can, are they still made here?
Yes, sir. Contra cartridge.
Yeah. Pretty cool. I think somebody here locally makes those things and provides them. That's kind of good.
And I help a lot with the redevelopment of the flares. We're always trying to make them cheaper. Silver is not cheap, so we try to back off on the silver, and we're finding other agents that we could put in there to help lessen the amount of silver we use.
One other clarification, just for people that might see or hear this, that I want to make sure that you're not creating hail.
No, in fact, if that's a great question.
People
because
will ask that. People will
I'm
hear
told
that
a lot of people in Coke County and East Tom Green County seem to think we develop hail. So yes, we're increasing ice within the cloud. But if you take a 5-gallon bucket of water and you turn it into 5 ice crystals, they're going to be pretty large ice crystals. What we're trying to do is take that 5-gallon bucket and turn it into 5,000 ice crystals. So by the time the ice is falling out of the cloud, it's warm enough, you get melting, it falls as precipitation. So weather modification is actually used worldwide as a hail suppression method. There's insurance companies in Canada that pay millions and millions of dollars a year for hail suppression to take place across their crops. Argentina is another example, tens of millions of dollars a year to protect their tobacco crop down there. So it's actually a hail suppression method. All you have to do is increase the dosage. You just put more flares into the cloud. But that's a great question. Thank you. So we'll look ahead to the climate, which in West Texas, who knows really. But I found these climate models that I'm about to show you to be pretty reliable. They've been really good in the past for climate modeling, and I've also looked at analog forecasts, which is basically taking the current conditions we've seen now and compare them to years in the past. And unfortunately, there's just what we're seeing right now is just nothing like what we've seen in the past 100 years. I simply can't figure out what our weather's been doing the last 6 to 12 months. But anyway, let's look at the climate models. This is for June and July, and it's showing the confidence in above normal precipitation or below normal. So the darker the green is not wetter, it's just better confidence. And the white is simply average. And for June, it looks like it's going to be pretty average. And then July, it looks like it picks up a little bit, especially down into South Texas, Austin, San Antonio area. But it's looking like it's going to come in a little bit over towards West Central Texas. So July is looking like a month that we could see above average rainfall. Once we get into August and September, it's summertime. We really rely on the pop-up thunderstorms for any precipitation, and the models are showing that. And then when we head into October, November, it starts looking pretty dry. which is surprising considering the Enzo El Nino Southern Oscillation, which I'll talk about here in a minute. And then moving on to December, it starts to pick up a little bit again. So looks like it could be an average to slightly above average summer, with average to below average fall as far as precipitation goes, and then winter looks like it picks up a little bit. Our weather here is primarily driven by Enzo, the El Nino Southern Oscillation. So we all know La Nina means it's going to be very dry. El Nino means it's going to be very wet, neutral. We're going to have our normal Texas weather. So the chart on the left there is your probability of one of the three, neutral, La Nina, or El Nino. And you can see through October, the August, September, October timeframe, we actually have a better chance of being neutral or El Nino than we do La Nina. And then when we go beyond that, we start to look at El Nino trying to develop, which could mean a wetter period for our winter time. It usually takes about 2 to 3 months before we start to see the impacts. We could be in El Nino, but we don't see the impacts for another 2 or 3 months. It's just a large-scale phenomenon that takes some time for the atmosphere to adjust to. However, a couple weeks ago, there was a much better chance of El Nino developing than what these charts are showing now. So really, these models are not sure what's going on. And the spaghetti plots over there are basically saying the same thing. On the bottom right, your black line is what's occurred in the past, and then your dotted black line is the average of those forecast models. And it goes down a little bit, comes up, goes back down. Forecast models are really struggling with the weather, not just the climate models, but the day-to-day models as well are really struggling with this weather pattern we've seen the last 6 months. It's been tough, really tough to forecast what's been going on. So my thoughts, it's been a pretty tough year so far through 2017, although May's helped a lot. We're at 6.48 inches for the year. Our average is about 7.02, so we're a little over a half inch below normal. It's been a wet May, which is great. We'll take it. But for the forecast, we will have to rely on the convective summertime storms to hold us near average through August. And then fall looks like we might dip below, but hopefully in December we could catch back up. So it'd be really nice to try to get a 20-inch year this year, I think, in San Angelo, which is right there on our average. Since 1950, our average is 20.95 inches. So it'd be really nice to get right there. But you can see the variability, like Bill was talking about earlier. The last 10 years, we've had a 35-inch year in 2016 and 2011 a 9-inch year. So it is a very variable climate here in West Central Texas, and simply it's tough to rely on any rainfall for water supply. Very tough. 35-inch year, you'd think our lakes would be full by now, but it just didn't do it for us. And with that, I'd be glad to take any questions or comments.
Good report. Thank you. Send me y'all want a hard copy? I mean, some of the graphs don't need, but I like some of the general information just to let people know. I think it's good. Jonathan, thank you very much.
By the way, this might be a good presentation for you to give to council at some point. Just
I agree.
Educate them on what you're doing.
Okay, next item, Bill.
The Texas Water Development Board has recently completed a brackish water study at the Lipan Aquifer, and that project was, Commissioner Bacon was very instrumental in getting that project done. And Matt Webb is here with us with the Texas Water Development Board, and he's actually presented that over at the county offices a month or so ago, and so some of you have seen this. But I thought it was a very good study, very good report, and I thought it'd be important for him to come and kind of give an abbreviated presentation today to you, so you can kind of see what they have discovered in looking at the Lipan. So, Matt, appreciate him being here, coming up from Austin to do this for the second time. So.
Welcome. Our traffic's a lot better here than it is in Austin.
What's that, sir?
Our traffic's a lot better.
Oh yeah, it's
You
nice.
move anytime you want to.
Nice drive up here. not a bad day to make the drive. So as Bill stated, my name is Matt Webb. I'm a hydrologist with the Water Development Board, specifically in the Innovative Water Technologies Group. And I work in the BRACS program, and we'll be talking just a little bit about the program itself, and then we'll kind of jump into the study. But before I move any further, need to give, this is just it's a standard Water Development Board disclaimer. What I'm going to be talking about today is the best science as we know it within our statutory requirements. But until the study is fully done, blessed off, nothing that I say at this point in time is an official position of the Water Development Board. Okay, so want to go ahead and talk about the study. As Bill has mentioned, this was requested in 2015 for the BRACS program is responsible for brackish groundwater modeling throughout the state. And whereas our brethren over in the groundwater ability modeling, or the GAM group, look primarily at freshwater, we actually not only account for fresh, but we also go and look for the saltier stuff, generally for regions that might be considering groundwater desalination as a water management strategy. And certainly the city of San Angelo has one on the books in the Region F plan currently. So the report, Bill had noted that the report was completed. I'll take a little bit of exception to that. It is not yet completed. It is in final draft review, which means it's not done to me at all. I get I get red lines from time to time as the thing is going up the management chain. Hard to know exactly when it's going to be published. So the report itself is not complete. However, we believe that the science is. And that's really what I'm here to kind of talk about today. So to talk about the actual geographic extent of what we were looking at, we took the existing Lipan aquifer outlines shown here in light blue, and then added a 4-mile buffer around that. We need to do that so that when we do surface interpolations and other kind of GIS things, that we don't have weird boundary effects. And that's represented by the dotted green line. Of course, sitting kind of smack dab in the middle of that is the city of San Angelo. So as I said, I work in the BRACS program, and our primary source of information is well logs. Be those geophysical logs, water well reports from drillers. And for this particular study, we looked at, we have a total of 7,000 wells we looked at, 6995. Not all those wells can be used for everything that we do, but you piece together what information you can get from this well versus what you can get from this well. And as far as our sample sources, I just don't want to go run down the list here, but it's just to let you know that we look at everything that we can find. All of our, it's kind of required because all of our data at the end of the report, everything is publicly available, and I'll talk on that a little bit later, which means that the information that we use, cannot be proprietary. Certainly, if we find some good stuff that happens to be proprietary, we work with whoever the holder of that information is to allow us to use it in a non-proprietary fashion, and we're successful in that in some cases. But you can see here, just a laundry list of everywhere that we went in this particular study to try to assimilate our what we call well control, basically the number of wells that we use. So a lot of wells. Of those 7,000 wells, the very first thing that we have to do is understand what the subsurface looks like geologically. The studies that had been done to date, at least those that are public domain, there may be some petroleum companies that have done some work that is sitting off in a vault or a server someplace that is not public domain. But for everything that we've seen, we think we did actually a pretty darn good job with stratigraphy relative to the stuff that had been done before. We took a look at 1,046 wells, 5,424 picks, and I'll talk about what a pick is here in a minute. And we looked at 15, we mapped out 15 Permian units. Basically, these are really old stuff, 250 million years old and older. And we identified 10 potentially water-bearing formations. One is the Quaternary Neogene sediments, basically what is kind of called around here, the Lipan Flats, which is the younger material that's kind of sitting on top of these Permian units. And basically the source of this is over the last several million years is the Concho River. When it's flowing, basically is eroding the Edwards Trinity plateau and kind of dumping it into the basin here that form the Lipan Flats. We did have, again, so 9 Permian units to make up the total of 10, so 9 Permian plus the young stuff. There's some other formations that we did map that are not specifically included in this study. We've got some mapping of a Triassic formation, which is the Dockham group, or the Dockham aquifer that is present really over to the west of the study area. Not a whole lot going on in the study area with the Dockham. And also the Cretaceous formation, the Trinity group, which is known as the Edwards Trinity Plateau aquifer, kind of encircles kind of the Lipan Basin. And those are actually going to be studied in future reports. We're just now really getting kicked off actually for both of these. I'm actually going to be on the Dockham team. And then we have another group within the BRACS program that's going to be doing an Edwards Trinity Plateau. We'll be doing stakeholder outreach, kind of starting to make sure that we talk to folks like yourself that are interested in these two aquifers here in the coming weeks and months. So what are making a pick? And I'm not going to get into a lot of the detail here, other than to say that geophysical well logs have a lot of well tools. They measure things such as natural gamma ray radiation in a formation, spontaneous potential. Again, I'm not going to get into all the details of this, as well as resistivity. Basically, when you drill a well, you drop a tool down. As you pull it back up, it takes a bunch of electrical readings and makes a bunch of squiggly lines on a long sheet of paper. And it's a geophysical well log. What we have here is just a snippet of one of those, and if you're very, very good, and one of the people that are on our team, a gentleman by the name of Mark Robinson, is very, very good at performing this. And what we see here is we see a pick here and another pick here. These are basically, this is the upper arrow there is the base, or is the contact between the Yates Formation and the Seven Rivers. And then there's one between the Seven Rivers and the Queen Formation. You can look, the squiggles change, and there's a bunch of reasons for those. And if you're really, really good and you've done it a long time, you can make sense of what all these things look like. So you go, and this is 2 picks. We did this 5,424 times. If you do it enough, you can generate surfaces from all of these picks. I'm not going to show you all of the surfaces. We have surfaces for all of the Permian formations, as well as the Neogene sediments. Just with time constraints, didn't want to show all those, but we have all of the surfaces. What I do want to talk about here is an actual cross section, and this is not some stylized artistical thing. This is actually done, based on numerical interpolation, and we take all these surfaces and we chop them sideways, and you look at them. This particular cross section, why is it not showing? Oh, animation. Okay, so basically we're looking at section BB that goes from there to there, so right through the heart of San Angelo. And what we can see is here over to the west, this is Trinity Group. So this is Edwards Trinity Plateau stuff. And here, what is symbolized in yellow is QT, is the Quaternary and Neogene sediments, kind of known locally. That's the Lipan Flats. And then you can see a large number of Permian formations, all dipping down to the west. So basically what we have is this yellow quaternary sitting on top of a lot of these old Permian units, and there's a big unconformity there. There's a lot of Jurassic and some Triassic material that's just been scrubbed off over time, which is one of the reasons, here you've got your Lipan Flats, which, generate some water, but when you go deeper, unlike if you're down in the Gulf Coast or something like that, you've had more difficulty, finding water. It's because all this stuff that's sitting down here is really old and highly cemented, but to varying degrees, and we'll talk about that in a moment. Oh, and just for your information, all of these, QTs and CHs and SRs, all of that is included, in this table. Don't know if you can, read it at what scale you're looking at, but it will be available in the presentation. So once we understand what formations we have at the subsurface, how deep they are, at that point, we try to go figure out, okay, what's the water quality that we can get from any of these formations? Well, where available, we look at actual water quality samples. Most of that, unsurprisingly, that we get is the fresher waters, because any of the drillers in this area and the operating wells, if they drill down until the point that the water starts getting salty, and then they stop. Well, what that means from a sampling perspective is that most of the samples that you get are fresher waters. Generally, here in this region, between about 600 parts per million of dissolved solids, up to generally around here you don't really get a bunch of samples over about 2,000. Which is slightly salty. Drinking water standards, just for comparison, here in the state of Texas are 1,000. So the question is, okay, we're looking for the saltier stuff, but we don't have samples. So what do we do to try to go estimate it at depth what those deeper salinities might be? And what you do is you calculate. Again, coming back to these squiggly lines on these geophysical well logs. There's a number of methods that you can employ to look at these squiggly lines to try to calculate a TDS. 7 of them that we generally employ. For a number of reasons, we picked a method called Alger-Harrison. We thought it to be the best and really the only potentially applicable given these old Permian formations that we were trying to take a look at. And again, what we're seeing right here is on the on these tracks over on this side, these squiggly lines, we actually took a pick there and a pick there, and you take some and you look at what the resistivities, the relative resistivities of those curves are. Again, it gets very, very complicated, and we did this on 179 wells, and this is one pick, and we did this 771 times. We did this, per formation. So I'm only going to show you one of the 9 Permian formations that we looked at. There's kind of a reason for this one. This is what's called the Upper Chosa member. If we were to go back to the cross sections, I could show you, which one that actually was. What we have here in the green triangles are actual water samples. As you can see, most of them are, within the kind of, a little bit below 1,000 kind of TDS level, up to about 2,500, and they're all relatively shallow. I will note that this is the depth below the top of the Permian Formation. So when we're doing all of this math, it's saying you take the Edwards Trinity and you take kind of the Lipan Flats and you scrub that off. We're starting to look into the into the older rocks. It's just a better way to look at it. But what you do see, is, sure enough, is that when you start to get, a little deeper, you don't have a whole lot of these green triangles anymore. That's where we start using that Alger-Harrison method that I referenced, which gives you the, blue diamonds that are all clustered here. And this method only works for a period, for a certain amount of geology. Once stuff gets really old, really tight, and at depth, what we start to see here, you can see this trend kind of going up in this direction, but then it starts to taper off. We don't believe that's because TDS is decreasing at depth. It's because of our math breaks down. The theories just don't work at that depth unless you have a lot of samples to calibrate to that we simply do not have. It is interesting. I think most of y'all may be aware of an exploratory drilling program that was performed by LGB Guyton here, published back in 2008. And they did drill a well and sampled a well that was completed in the upper chosen member. It's this well right here. That was at 903 feet, so 800 or right at 800 into the Permian formations themselves. And sure enough, where all of these, like I said, this trend started to taper off. If we take a real sample, sure enough, it actually does continue trending. So when we did all of our calculations, everything that has the red squares there, we discounted them. We don't count them, can't rely on them. But that's actually, kind of okay because even if we believe these values, this stuff is up around the 15, 20,000 TDS. Even if we trusted it, so that's pretty salty. Salt water, seawater is 35,000. And generally speaking, to do groundwater desalination, you're really looking kind of the sweet spot is between kind of there and there. Above that, things just start getting expensive. Energy costs to go run your RO membranes and things of that nature become problematic. So all of these were developed for a bunch of different formations. And what we ended up doing is averaging within certain zones. We would take a zone there, so a zone there, a zone there, a zone there, and we would average any data points that we had within the specific intervals. Did that for all of the formations. I'm not looking at my thing. I hope I'm going to the proper slide. Yes. So as the bullets say, and as you could see in the prior slide, there is a significant amount of data scatter within each zone. We averaged by depth intervals, as I'd kind of shown with the red lines on the prior slide. These values are averaged across the formation to determine regional relationships. So what we're trying to find is, okay, between 0 and 1,000 TDS, kind of what's the amount of total water that's here? Then between 1 and 3, how much do we have? Between 3 and 10, how much do we have? And we would have liked to done between 10 and 35, but as I showed you on those other slides with the red squares, the math breaks down. We just can't do it. What we did have here is depth below the top of the Permian. These are 4 of the 9 Permian units that we consider to be potentially water-bearing. And as you can see, there's quite a bit of the Queen Formation. The information that we have there says as soon as you touch the Queen, you're not going to get anything out of the Queen that's not 3,000 or greater TDS. You can see that by the 0. You do see San Angelo Formation here of 205. It's like our math indicates that you can actually get into the San Angelo a little bit before the water gets really salty. What we're not saying here is how much of that water you could get out of the ground, which is a function of hydraulic conductivity. Here all we're trying to solve for is volumes of water by salinity zone. And to get a regional average, we basically took all these numbers, did an arithmetic average, and we said below top of Permian, you can go 105 feet until you get to the base of your slightly saline water, which is your 3,000. Again, relative to the top of the Permian, you can get about 300 feet regionally, and then you're going to start hitting the 10,000 TDS, so pretty salty stuff. So kind of, this is stylized. but it talks about the methodology that we use to calculate the volume of groundwater. So what we looked at is when you're looking at these, zones, well, you got to, the very top, which is this, the blue line is static water level, which is, where's the top of the water in the subsurface. And for that, we used static water level readings from January of 2000 to present. Didn't want to use anything earlier than that. Just wanted everything to be contemporary. And we developed a surface on what was the top of the water underneath the subsurface. And then when I talked earlier about that 105 feet until you get to the base of the slightly saline, that's basically from there to there. That's 105. From there to there is that 328. And what we believe to be true is that the fresh water is either in the Trinity group, so the Edwards Trinity Plateau stuff, or it's within these quaternary and neogene sediments over in this area. So you get this, this line right here. If you get water above that, okay, we believe that to be fresh. So you do a lot of, kind of three-dimensional calculations and this kind of stuff based on this concept. And so some of this I've already kind of spoken to. We talked about the top of the saturated zone is based on historical static water levels. Then what we initially calculate is how much rock is there in these particular zones, and then you say, okay, well, how much water is within that rock? Because most of the rock is rock, but some of that rock is actually pore space that is occupied by water. The values that we used was 0.05, so that's a ratio, how much of the volume is water versus how much of it is rock. And in the young, kind of the Lipan flats kind of materials, as well as in the heavily weathered Permian. So some of this Permian that's close to the surface, does get flushed a certain amount from rainfall and what we call meteoric rain or meteoric water. And over time tends to kind of break and weather that stuff up. It gets a little bit more pore space. Once you start getting into this moderately weathered Permian, things start to get real tight. This stuff is over 250 million years old, and it's been getting crunched on for quite some time. It's heavily cemented, so very low ratio of water to rock. So you apply those calculations, or these percentages to those formations, and you get the table at the bottom. It's broken out by formation. Basically, what we're saying is, again, up in that kind of Lipan flats, kind of area, we calculate 171,000 acre feet of fresh water. Just as a general sanity check, went back and looked. So the regional left plan shows that in 2010, out of the Lipan, in the 3 counties that reported Lipan pumpage, Tom Green, Concho, I can't remember the other one. Reported 28,000. If you look at that 28 and compare it to 171, it's like, well, wow, there sure was a lot more water there. And as a matter of fact, yeah, there was. We're not saying that you can get all 171,000 acre feet of that water unless you took all of that and squeezed all the water out of it. So by ratio, that 28,000 is about 16% of the 172 that we calculated. So it was just a qualitative sanity check. I was like, does that sound about right? And it's not bad. If this number right here had been 250,000 acre feet, we'd have been like, okay, something's wrong with our concept. But it is a sanity check. It didn't look bad. What we can see is in that the slightly saline zone, the stuff between 1 and 3, there's an awful lot of water there. We believe it varies by formation, and then once you get down into the 3 to 10, there's not a bad amount of that either. But so kind of our conclusions from this is the groundwater volumes that we need to kind of make sure you understand. The groundwater volumes are based on these regional averages. So when I showed that slide about 4 slides ago, I was like, your depth to the 3,000 line, as I said, in the Queen, there's not one. As soon as you tap the Queen, you're 3,000. Versus, as I'd said, the San Angelo, you actually, get some, have some depth. When we actually did our volumes, we did not apply those discrete depths by formation. The math got really, really difficult, and that really was beyond our scope. What we were trying to look at was, regional averages of total available, or total existing, I shouldn't even say available, total in place. And that really gets to this next point. Not all of this is going to be economically or technically, recoverable. You'd have to poke a whole lot of holes to touch, all of this water. In here, again, I just kind of, summarize the fresh, slightly saline, and moderately saline as we had seen in the, in the prior table. One of the things that we do think is important here, and it's something that we pride ourselves in, is that all of the data that we collected from all of those sources that we showed you up in the second or third slide, once the report gets made public, all that data is available for anyone to look at. It's one of the things, sometimes if you will get it, and nothing against the consulting firms, but one of the things that can be true is that some of these reports, you can get these, you'll get these pretty maps, and they'll say, okay, we used, well here, here, and here. But you don't actually have the geophysical well log. What if that guy was wrong? What if you wanted to go, or have someone else go, look at that data to see, did they interpret that right, or is there maybe another way to interpret it? With our stuff, we're, kind of like y'all, you'd mentioned being transparent. We're totally transparent. We're going to show you every piece of data that we have, and if you think we did something wrong, by all means, go and improve it, and hopefully let us know, what you found that was better than what we found. So that's all the well data and the geophysical well logs, all the calculated parameters that we have, all these, salinities, all of those, blue diamonds and all that kind of stuff. The raw data as to where we got all that. All the GIS files. I didn't show a whole lot of GIS files here because, just because of time constraints, but we actually have 3-dimensional surfaces for static water level, salinity zones, all of these Permian formations. All that will be, made public. And it's not that it's in the last little bullet here is that the data is not, it's not just boxes and boxes of geophysical logs. It's all organized in a Microsoft Access database, for data management, being able to run queries, and all that kind of stuff. So we really think that that's one of the keys to the BRACS program is we share everything that we've compiled. So one of the the takeaways here is that there's quite a bit of water, we believe, between 1,000, 3,000, TDS. What we were not able to do is tell you, okay, go drill on that corner in Bob's Ranch, and that's where you're going to be able to plug into that 4 million acre feet. It's those type of site specific. Evaluations need to be done very site specifically, and we did a lot of generalizations because this was a regional study. Like as I said, the report is in review. All of this data will be made public once that review is done. And that kind of concluded our study, and I'll kind of open things up if anyone has any questions for me.
So, Bill, it's up to you to figure out where that spot is where we can go get that 1 to 3,000 and we'll solve all our problems, right? Good report. No, we appreciate, Matt, you coming. That's very interesting. Thanks for doing it.
Thank you, gentlemen.
The Commissioner for getting it kicked off.
Kind of a little bit of historical perspective. 5 or 6 years ago at the legislative conference that the Chamber and partners do out, that was held out at ASU, was on water issues. And the head of the Texas Water Development Board was there, and I can recall him making the comment is that Texas does not have a shortage of water. It has a shortage of cheap, fresh water. He said, we have plenty of brackish water at that time. I do know there was a lot of preliminary studies out there. Of course, this was explored. How long ago has the one well,
The Schmidt well, the report came out, and you're talking about the Guyton exploratory well? Yeah, 3 total wells, a couple of dry ones, one that produced a bit. The Schmidt well, that was actually published in 2008. The drilling program itself was, I think, 2006, 2007.
Well, as approximately 4 or 5 years ago, before I left the commissioner's position, we were getting a lot of comments and questions from citizens that wells were going dry. Obviously, Mr. Weiss was right in the middle of that. Their supply was struggling, and there was a number of things that were somewhat going on. It seemed to be some recent advancements in the desalinity process. And then as the city somewhat moved forward and the revelation that primarily the process for the potable reuse is basically the same as desal, there was a lot of things going on. That's the reason that as we transitioned to Commissioner Bacon into my position, and knowing the pressure that was on the groundwater supply and how crucial that had been to the development in the rural areas of this county, whichever direction that you want to go, it just seemed like that was the time to try to request. And I thank the Texas Water Development Board for being receptive, and I think moving us up on the list of those studies. Now, the county were successful in receiving 3 of the Texas Department of Agriculture emergency grants to go in to try to supplement the water supply and some of our CNN holders that were providing water. So we're just fixing to complete the last one of those. So it's kind of been somewhat of an overview that got into a little bit of the broader look for water other than just municipality within the city limits of San Angelo. Try to look at it in a regional scale. So we were glad. We have been anxiously awaiting the results of y'all's study. So
Well, we sure wish we could have delivered you a silver bullet on, where to go find some of this, slightly saline water. It's just you suffer from, geology. You don't have a whole lot of young stuff sitting on top before you get really hard and really old.
Mr. President, can I ask a question? Sure. So when do you expect the final approval, and when do you expect to publish it?
I would say with confidence. Certainly, this calendar year, I would love for it to be earlier than that, because that can mean that I'm done making edits from the bosses. But it is right now, moving pretty well. What is it right now? We're getting ready to be June, July, August. So before end of year, but certainly sometime in hopefully early 4CQ, but I can't make a commitment.
Early what? What'd you say?
Fourth calendar quarter.
Okay. So my next question is for Bill. So I guess you brought the presentation, I guess, for a reason. I mean, I think it's really good information. So does that mean that we look at this as a potential water supply strategy? I remember we went through that SWOT, and brackish was very low score, high cost, and potential wasn't there. So does this move it up, and should we look at a site-specific study that we need to try to fund? And just a question.
It's actually just the opposite. I think it proves the point that it'd be a major wildcatting effort to go out and try to find any significant water, and it would take hundreds of wells to be able to produce the water. So I think it's actually, for San Angelo, for a significant water supply, it just kind of proves the point that that's just not available to us at this time.
Okay.
Anything else?
No, sir. If y'all
We
are
sure
done with me,
appreciate
I'm
you coming.
finished.
Thanks for your report very much.
Thank you very much.
Yes, sir. Bill, anything else? I only have one thing. I asked Bill a while ago, because I've been receiving a lot of questions about the land purchase in Brady and what was going on, and wanted to know specifically if the Water Advisory Board could go into executive session, i.e. to learn a little more about Hickory Aquifer and some of the things that are associated with that from a legal standpoint, and then to learn more about the purchase and the legal rights that was going on with that. So I've asked the city attorney to give us a written response. And the bottom line is, no, we can't. We're an appointed board. Certain boards have authorization, but we do not. Everything we do is in open meetings, but I know a couple of you had asked me for that, and so I'm a writing guy. I wanted a written explanation so we know, we're just not privy to what goes on there. I know in talking to council, and as soon as that was broken, especially about the land purchase, depending on those water rights, we got phone calls. And we said, we don't know, we're not entitled to that information. And the public doesn't understand that, but it is what it is. But I wanted you, in case somebody asks you again, it'll be in things coming up now, we can at least tell them we do what our charter is, and that's it. Okay?
And a good point. And to clarify, I think the members of this board knew at the same time the general public did about the purchase of that ranch. I think I'm confident in saying.
Yeah. So, any other business? Stan?
Maybe a suggestion, and I don't mean to put more work on you, Bill and Allison, but the thought struck me as we kind of going back to the discussion a little while ago, Mike, particularly having had some months of lag since we've last met, but I just wondered if it might be helpful if we developed some kind of little tracking log, a simple matrix of things that have gone before this group or that should go before this group, to help us kind of bridge those gaps of time. That would just be, it could include a little bit of a status update or something along the way that just kind of helps keep us fresh, because I know you guys are working on and thinking about this stuff day in and day out, and sometimes when several months pass, we don't necessarily remember all the details of what it is that we did approve, that, like you said, you're going to be putting before council next month. And so maybe some instrument, and I'm a big believer in not creating monsters that require a lot of upkeep and maintenance. So I'm not asking for or suggesting that we do some very complex exercise here, but maybe something, I've got some additional thoughts or ideas that I use in my work that might be helpful on that front. So, just a thought.
Yeah, that's fine. Appreciate it. Anybody else?
I just want to apologize to the media staff. I may request a remote or a portable microphone next time to kind of match my bobblehead delivery stuff.
Noted. So, next meeting date, I mean, I know there's not a lot, it's summertime, but if we could kind of figure out when our study's coming on the infrastructure project and tie our meeting date, if it's not too far in the future, to that. And then that'll give us also a 6-month forecast on 17 on water rates, where we've been. I think it's a good time. It's mid-year. You can say, hey, here's where we plan on being, here's where we actually been, just so we get that 6-month forecast. We can also include that, and then that, it keeps us involved and the community involved on what's going on, and let them know where we are. I'd like to do
We're
that.
anticipating probably late July for the next meeting, that we should have that study and be able to have that discussion.
Okay. You want to try and set a date, or do you want us to wait till we kind of let's get a little bit closer, maybe around 1st to the 4th, and we can look and shoot for a date towards the end of July? Okay. Is that all right with everybody? Yeah. Any other business to come before us today? Bill, Allison, anybody? Okay. If not, we're adjourned. Thank you.